Supervised and unsupervised learning are two fundamental approaches in machine learning, each with distinct methodologies, objectives, and use cases. Supervised learning relies on labeled data, where the input data is paired with corresponding output labels. The model learns to map inputs to outputs by identifying patterns in the labeled dataset, making it ideal for tasks like classification and regression. For instance, in email spam detection, a supervised learning model is trained on a dataset of emails labeled as spam or not spam, enabling it to predict the category of new emails. This approach is particularly effective when a clear relationship exists between inputs and outputs and sufficient labeled data is available to train the model. In contrast, unsupervised learning deals with unlabeled data, where the goal is to uncover hidden structures or patterns without explicit guidance. The algorithm explores the data's inherent properties, often clustering similar data points or reducing dimensionality for better visualization and analysis. A common example is customer segmentation, where an unsupervised learning model groups customers based on purchasing behaviors without prior knowledge of predefined categories. This approach is beneficial when labeled data is scarce or non-existent, and the objective is to gain insights or discover meaningful groupings within the data. Deciding which approach to use depends on the problem at hand and the nature of the data. Supervised learning is the go-to choice when the task requires specific predictions or classifications based on historical examples, such as forecasting sales or diagnosing diseases. On the other hand, unsupervised learning is more suitable for exploratory analysis, where the aim is to identify patterns or relationships that were previously unknown, such as detecting anomalies in network traffic or recommending products based on user behavior. By understanding the strengths and limitations of each approach, one can effectively harness their capabilities to address diverse machine learning challenges.